Welcome to the Spelling Bee Ninja podcast, where we unlock the world of learning in fun and engaging ways. If you're ready to master essential skills in mathematics, you're in the right place. Subscribe for free to join our community of curious minds as we explore fascinating educational topics together. Today, we're diving into the intriguing world of square roots, a concept that is more essential than you might think. Square roots are foundational in mathematics, yet they often surprise learners when they first encounter this concept. Did you know that the square root of 2 was so perplexing to ancient Greek mathematicians that they tried to keep it hidden? This leads us into our exploration of square roots, the operations that are essentially the inverse of squaring a number. When you square a number, you multiply it by itself. The square root, on the other hand, answers the question, what number multiplied by itself yields the original number? For example, the square root of 9 is 3 because 3 times 3 equals 9. The notation we use for square roots is a radical sign, which looks like a checkmark, square root. This symbol is recognized in mathematical circles as the square root symbol, and it has a rich history in mathematics. Understanding how to use it is crucial for working with square roots. Now, let's talk about perfect squares. Perfect squares are numbers obtained by squaring whole numbers. Some examples include 4, which is 2 squared, 9, which is 3 squared, and 16, which is 4 squared. Each of these has a whole number square root, 2, 3, and 4, respectively. Recognizing perfect squares can help you quickly identify the square roots of these numbers. Moving on to how we find the square roots of perfect squares, it's all about determining the side length of a square when given its area. If the area of a square is 64, for example, we ask ourselves, what number multiplied by itself gives 64? That's right, 8. Now, things get a bit trickier with non-perfect squares. If you want to estimate the square root of a number that isn't a perfect square, you can compare it to the nearest perfect squares. For instance, let's take 50. The perfect squares closest to 50 are 49, 7 squared, and 64, 8 squared. Since 50 is between 49 and 64, we can conclude that the square root of 50 lies between 7 and 8, specifically a value that's a little higher than 7. As we simplify square roots, we often look to factor out perfect squares. Let's return to the example with 50. To simplify the square root of 50, we notice that 50 can be factored into 25 times 2. Since 25 is a perfect square, we can express this simplification as square root 25 times square root 2, leading us to 5 square root 2 as the simplified form. Square roots are not only vital in basic arithmetic, they play an important role in geometry as well. One of the most well-known examples is the Pythagorean theorem, which describes the relationship between the lengths of the sides of a right triangle. If you have a right triangle with legs measuring 3 and 4, you can use this theorem to find the length of the hypotenuse, which is the side opposite the right angle. According to this theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Hence, we calculate 3 squared plus 4 squared, equaling 9 plus 16, which totals 25. The square root of 25 then gives us a hypotenuse of 5. Isn't that fascinating? Now, let's not forget that square roots are everywhere in our daily lives. They pop up in construction, navigation, physics, and even in computer graphics. In construction, for instance, knowing square roots aids in measuring lengths accurately. Also, if you've ever used a GPS to navigate, it might surprise you to learn that square roots are used in the calculations of distances between points. These practical applications underscore how crucial it is to be familiar with this mathematical concept. To add a historical dimension to our understanding, square roots have been examined for thousands of years. The ancient Babylonians were among the first to approximate square roots, and later on, Greek mathematicians expanded on this knowledge. Their work led to the discovery of irrational numbers, numbers that cannot be expressed as simple fractions. A prime example is the square root of 2. This value cannot be expressed as a fraction, which baffled mathematicians for centuries. Understanding these historical contexts gives you a clearer picture of how square roots evolved over time and why they are so significant today. As you delve deeper into mathematics, remember that mastering square roots can open the door to more advanced concepts and applications. They form the basis for understanding geometric dimensions, calculating areas, and solving equations, essential tools for any budding mathematician. Today, we explored the concept of square roots, learning that they are the inverse of squaring numbers. We discussed how to recognize and use the radical sign, identify perfect squares, simplify square roots, and employ the Pythagorean theorem in geometry. Additionally, we touched on the historical significance of square roots and their practical applications in our everyday lives. This understanding sets a strong foundation for further studies in mathematics and its applications. Thank you for joining us on this journey into the world of square roots. We hope you found this exploration enlightening and that it inspires you to delve deeper into mathematics. Don't forget to subscribe to the Spelling Bee Ninja podcast for more engaging educational content, as we continue to discover new subjects together. Until next time, keep learning, keep asking questions, and remember, the world of knowledge is at your fingertips.